When you first look at it, it seems so serene, doesn't it? Just this beautiful celestial flower spinning peacefully out there in the void. But the Sunflower Galaxy is hiding a pretty violent secret, a story of cosmic cannibalism that's written in these faint, ghostly trails of starlight. So let's dive into this cosmic crime scene.
Okay, so here it is. This is Messier 63, but pretty much everyone knows it as the Sunflower Galaxy. It's this absolutely stunning spiral galaxy, about 29.3 million light-years away from us, over in the constellation Canis Venatici, which means the hunting dogs. And fun fact, it's actually part of a little galactic neighborhood that includes the even more famous Whirlpool Galaxy, M51.
All right, so let's start with what we see on the surface. I mean, why is it called the Sunflower Galaxy? Well, the answer is written right there on its face, in those beautiful, kind of patchy spiral arms. M63 is what astronomers call a flocculent spiral. Now, unlike some galaxies that have these huge, grand, sweeping arms, a flocculent galaxy has arms that are short, patchy, and kind of broken up. You can totally see how these little segments look like the petals of a sunflower, right? It gives the whole galaxy this fluffy, really distinctive look. And the theory for why it looks like this is actually, it's pretty simple and elegant. The idea is that you get a little burst of star formation somewhere in the disk. Then, as the galaxy rotates, that whole pocket of brand new stars gets sheared and stretched out, which creates these short, disconnected little pieces of spiral arms. It's a great explanation, but as we're about to see, it is not the whole story. Right, so M63's fluffy appearance starts to get a little complicated when you compare it to its neighbors. And that brings us to a really fundamental question in astronomy. How do any spiral arms manage to survive at all? Okay, check this out. On the left, you've got our flocculent sunflower, M63. And on the right, you have a classic grand design spiral, like its neighbor, the Whirlpool Galaxy. The difference is just, it's immediate. M63 is all patches and pieces, while a grand design has these incredible, well-defined arms that wrap all the way around. Totally different vibes. And this brings us to a classic puzzle that astronomers call the winding paradox. See, a galaxy's disk doesn't spin like a solid vinyl record. Stars closer to the center are whipping around their orbits way faster than stars farther out. So if the arms were just made of stars, they should get wound up incredibly tight in just a couple 100 million years, which would totally destroy the pattern. I love this analogy for the problem. It's perfect. The stars on the inside track would lap the stars on the outside track over and over and over again, and any pattern would just get smeared into a complete blur. So something else has to be going on. So for those big grand design galaxies, the solution is that the arms aren't actually made of the same stars all the time. They're what we call density waves. Think of it like a traffic jam on a cosmic highway. Stars and gas, they slow down as they move through the wave, they get compressed, which triggers a burst of star formation, and then they move on out the other side. The wave, the traffic jam pattern, stays, even as all the material flows right through it. But what about our galaxy, M63? This is where it gets really interesting. The light we normally see is dominated by young, super bright stars, and it's all obscured by these dark lanes of dust. But when astronomers use near-infrared telescopes, using a kind of light that can cut right through all that cosmic dust, they could finally see the underlying structure, the older, cooler stars that make up most of the galaxy's mass. And what they found was, well, it was incredible. And bam, this is the first big secret. Hiding underneath all of that fluffy, patchy chaos, there is a faint but definite two-armed grand design spiral. Now, it's way weaker than what you see in the Whirlpool Galaxy, for sure, but it proves that M63 does have an underlying density wave after all. The Sunflower isn't just a simple flocculent galaxy, it's some kind of hybrid. Finding that hidden structure, that was a huge clue, but it was only the beginning. Turns out, the biggest secret of the Sunflower Galaxy wasn't hiding in its bright disk at all. It was lurking in the vast, dark emptiness all around it. So what happens when you take a really, really long exposure photograph of a galaxy like this? You expect to see the faint, fuzzy glow of its stellar halo. But with M63, astronomers found something else entirely, something long, looping, and completely unexpected. Just take a look at this. The image on the left, that's a deep exposure of M63. But on the right, where they've pushed the contrast to the absolute limit, whoa. this giant, ghostly arc of stars just appears, looping way, way out into the galaxy's halo. This is the smoking gun.
So, what is this thing? Well, that arc is a stellar tidal stream. And to put it bluntly, it's the shredded corpse of a smaller dwarf galaxy that got a little too close to M63. Over millions of years, M63's massive gravity literally ripped the smaller galaxy to pieces, stretching its stars out into this enormous river in the sky. This is direct, undeniable evidence of galactic cannibalism. And just to give you a sense of scale here, the visible part of this stream stretches for 29 kiloparsecs. That's nearly 95,000 light-years long. That is almost the diameter of our entire Milky Way. So this isn't some tiny little feature, it's a monumental structure wrapping around the galaxy. So now we can reconstruct the crime. A few billion years ago, a satellite galaxy got captured by M63's gravity. As it orbited, it was slowly, relentlessly pulled apart. What we see today is the fossil record of that ancient collision, the starry remains of a devoured galaxy. But you know, eating an entire galaxy isn't exactly a neat and tidy affair. It's messy business, and it left its mark all over M63. And this is what likely explains a lot of its other really strange features. This detailed view is so cool because it doesn't just show the main stream, that's labeled A right there. It also points out other faint plumes and weird shapes in the halo, labeled B, C, and D. These are probably other pieces of debris from that same merger, or maybe even scars on M63's own disk from the impact. And the effects go even deeper. Astronomers have known for a long time that M63 has a severely warped gas disk. It's tilted by about 20 degrees. It also has this strange thing called an extended ultraviolet disk, which just means stars are forming surprisingly far out from the center. And guess what? The gravitational chaos from this merger is the perfect explanation for all of it. It warped the disk, it compressed gas to trigger star formation, and it probably even kicked some of M63's own stars right out into the halo. This color map just perfectly illustrates one of those consequences. The blue and green spots show where there's recent hot star formation going on. And just look how far out they go, way beyond the main part of the galaxy we normally see. That's that extended UV disk, and its existence is almost certainly a direct result of the merger shocking the gas in the galactic suburbs and kicking off a whole new wave of starbirth. So, let's pull all these threads together. The Sunflower Galaxy is so much more than just a static, pretty picture. It's a dynamic, evolving system, and we caught it right in the act of growing. And here it is, the crucial point. The serene beauty of the sunflower is a direct result of its violent, chaotic past. The gravitational mess from that merger is what's likely triggering all the patchy, off-kilter star formation that gives us those flocculent petals. So its signature look, its warped disk, and its hidden grand design, they're all linked back to this ancient act of galactic cannibalism. M63 is a living laboratory, showing us in real time how big galaxies like our own Milky Way get built one cosmic meal at a time. It really makes you wonder, doesn't it? When we look out at the billions and billions of other galaxies, each one just a tiny pinprick of light, how many of them are hiding similar stories of collision and creation, just waiting for us to uncover them? What other cosmic stories are hiding in plain sight?